Combine only like terms or things or tags. Why? Let me ask you a question so that I can show you that you already have a sense of why that is true. What is 2 quarters plus 3 nickels? I will bet your answer is 65 cents. Not 65 quarters, not 65 nickels, not 5 quarters, not 5 nickels. Before you can add numbers, you have to know, you already have a gut feeling that they have to be representing the same kinds of things. 3 nickels plus 2 quarters just doesn't make sense until you translate them both into pennies. 2 quarters is 50 cents. 3 nickels is 15 cents. The answer is then 50 plus 15, 65 cents. You can add 3 nickels and 2 quarters and get 5 coins, 5 things, 5 objects. You can't get 5 nickels, you can't get 5 quarters. But if you change them to just generic things, objects, stuff, coins, well then that works. It's the same way. 3 apples plus 2 oranges, 5 pieces of fruit. See, now you take away the appleness of the fruit and the orangeness of the fruit, and you get 5 fruits. You're making them very generic. You're making them the same things. 3 nickels, 2 quarters, 5 coins. 3 nickels, 2 quarters, 65 cents. We can combine only like things because that's the only thing that makes sense. Pun intended. Here's another quick lesson on combining only like tags. If we have 2/3 and we add 1/3 to it, we expect our answer to still be thirds. I mean, after all, that's the question we were asking. So the answer is going to give us something similar in return. They're not magically going to change into something else. Again, for example, in the real world, if we have thirds, if we add 2 of them and 1 of them, we're going to still have 3 of the same thing. So now translate that into numbers, because numbers are supposed to be representing real life. And so if we have 2/3 plus 1/3, we're still going to get thirds. So combine only like terms and get only a like term. Combine only like terms using saddle. Same signs add, difference destroy, largest sign is the answer sign. That's just the quick mnemonic of the 3 rules over here, 1, 2, 3, and we're going to see how they work. One quick note before we do that, notice that we are combining blank tags with blank tags to get blank tags. If one of these numbers had something else in it, an X for example, then I wouldn't be able to do it. Tags have to match, as we've seen in previous lessons. Okay, let's look at the numbers. I put these up here so you could notice the pattern. First of all, step 1, the biggest number is on top. All the way across, the 7's on top. Step 2, the top sign is always on the bottom, all the way across. Negative, negative, positive, positive, negative, negative. Step 3, look at both signs and notice that they're the same, so I add bigger. 7 plus 2 is 9. Notice the signs are the same, so I add bigger. 7 plus 2 is 9. Notice the signs are different, so I subtract smaller. I destroy. 7 minus 2 is 5. Notice that the signs are different, so I subtract smaller. 7 minus 2 is 5. The pattern always holds. Those are the 3 steps. They will never change. Combine only like terms using saddle. Here I'm using bigger numbers. But I think you can quickly see the same patterns hold. All across the top. The biggest number is on the top. The sign on the top is always the answer sign. Always. When the signs are the same, I add bigger. Signs are the same, I add bigger. When the signs are different, I subtract smaller. Signs are different, so I subtract smaller. That's it. Always works. Big numbers, small numbers, doesn't matter. When you're combining those 3 steps, they always work. Okay, here is a little complication with our combining. And that's because there is a touch of multiplication thrown in. First of all, a little geekish background on the notation. Almost always, when 2 things are next to each other, that means multiply. Got to say almost always because, for example, 1 next to 1 does not mean 1 times 1. That is an 11. 10 plus 1, 11. But in other cases, for example here and here, they are next to each other. Those signs are multiplying each other, which means we pull in the nope principle from the mud action. Nope, I'm reading from over here. Nope applies to signs in front of each individual number, not to the whole problem, because the whole problem isn't multiplying. The numbers aren't multiplying each other, only the signs. Only the signs are touching each other, so only they are multiplying each other. So for example, minus times minus, or negative times negative, or subtract times subtract, wording doesn't matter. Just look at the sign, 2 negative signs next to each other. And that means they're multiplying. That means you use nope, negative, odd, positive, even. I have 2 negative signs multiplying in this string of signs, so they become positive because 2 is even. So 4 minus a minus 7 is exactly the same as 4 plus 7. Okay, let's come down here. A negative 8 comes over here to a negative 8. Now we have a positive and a negative in front of the 4. Well, which is it? Is 4 positive or is it negative? Ignore the plus sign. Count only the negatives. There's only 1. That is odd. So 4 is negative. Now, here's this next problem down here is a favorite of many books. And it's still beyond me how this makes things easier for anybody. But this is what we've got to deal with, so let me just show you how to do it. We have a minus sign next to parentheses. That means multiply. I've got a minus times the positive 7 inside. So what is a minus times a positive? Well, it's the exact same as we had up above, even though there are no parentheses. The parentheses are just another way to show the same old thing, the negative next to something, so you multiply. So that means you use nope. That's the bottom line. The 9 is blank, so it is positive. Still positive over here. You can put the plus sign in front, of course. We've covered that already. Minus times a positive, so I just use nope. Negative odd, positive even. There is a negative count of negative, there is an odd count of negative signs. Odd is negative, the 7 is negative. Same way down here is just you got the plus sign outside and the negative sign inside, but it's still multiplying. So the -3, of course, is obvious. It's still a -3. And here's another thing. In case you forget, let me show you this. We have a blank sign, which means we have a plus sign in front of the negative. And I could have 5 invisible plus signs in front of the negative. Still going to be negative. So only negatives count. Plus signs don't change anything. The negatives will reverse what's ever there. So now I've got a +5, except it gets reversed by the negative. So I have a -5 over here. Down here, we've got a +11. So it still stays a +11. Now we've got a -2, but it's multiplied by, it is reversed by, negative odd, positive even. There's 2 of them. So different ways of arriving at the +2. But no matter which way you do it, you end up with a +2. Yet another way of looking at it is to take the negative. Let's take this one over here and we move it. And then it rotates. So that's one way to visualize it. So the negative comes in there and multiplies by the negative that's already there. And every time you do it, that negative rotates and joins with the negative there, becomes a positive. Well, and then that just kind of cancels itself out. And we're still left positive, blank, plus sign, however way you want to look at it. And we have a +2. Okay, again, down here, we can ignore all the plus signs in front. We have 3 negatives. 3 is odd, so 2 ends up being negative. We have this negative joins with that negative. They cancel each other out. And we have a negative. Nothing cancels it out. We still have a -2. If we just go along and start at the left, negative, positive doesn't change it. Negative reverses, so now it's a +2. Positive doesn't change it. We're still at +2. The negative reverses, we get -2. That's how we end up with. But you see, either way, the underlying governing principle is negative odd, positive even. Because reversing a reverse sends you forward again, which means positive. So evens cancel themselves out to positives, and negatives or odds always have one negative left over, one unreversed reverse, and that's why you end up negative. So the same way here, we have a negative, positive doesn't do anything, negative reverses our first negative, so we end up positive. 2 negatives, even becomes positive. So look at the example, see that it is nope, and see how only those signs in front of the numbers are multiplying. The numbers themselves, as you can see here on the right, are not multiplying at all. They're combining. So it's like inside the 2 parts of the combining, inside each part, there are tiny microscopic multiplications going on with the signs. Hopefully that helps. If not, maybe you can help me with a better illustration. But the overall problem is not multiplying or dividing. The overall problem is combining, and only the negatives and the signs in front of each number are multiplying themselves. And so each little set of signs uses the nope rule to come up with its own answer just for that number. Then you're able to proceed with the rest of the problem as normal.